Now let's have more problems on sampling distribution of means. So again, never be confused. If given the population mean, population standard deviation, sample mean, sample size n. So to convert x bar to z-scores, we need to use the formula z-score is equal to x bar minus the population mean all over population standard deviation divided by the square root of the sample size. Okay? Now, if we are given the population mean and population standard deviation, so to convert a raw score, not necessarily a sample mean, just z, just x, not x bar. So to convert x to z-score, we use the formula z is equal to x minus the population mean all over the population standard deviation. So in the case of using this formula, you need to make sure that you are dealing with data about the sample means. So you should read the problem properly. You should have a hint that what we are looking for or what we are given are data that is about the sample means. But if we are dealing with an individual data obtained from the population, then we'll use this formula in converting raw score into corresponding standard scores. Okay? So let's have example 1 here. The average time it takes for grade 11 students to complete an examination is 46.2 minutes. The standard deviation is 8 minutes. So assuming that the distribution of time is normal, what is the probability that a randomly selected student complete the examination in less than 43 minutes? So you already know here that average time refers to the population mean, which is 46.2 minutes. And the standard deviation also is a population standard deviation, which is 8 minutes. And here, what is the probability that a randomly selected student complete the examination in less than 43 minutes? So here we are dealing with individual data that is obtained from the population. So you already have an idea which formula for finding the z-score will we use. Is it the first one or the second one? Okay, so solutions, again, step 1, we identify the given. So population mean is 46.2, population standard deviation is 8, and your raw score or x is equal to 43. This is not x bar because this is not a sample mean. Clear? Now, identify what is asked. So in the problem, the question is what is the probability that a randomly selected student completes the examination in less than 43 minutes? So what is asked is the probability of x to be less than 43. Next, identify what formula to use. So here we assume that the distribution is normal. So the area under the normal curve can help us to determine the probabilities. We are also dealing with an individual data obtained from the population. Hence, we will use the formula Z for finding the z-score is equal to x minus population mean all over the population standard deviation. Again, we use this formula because we are dealing with an individual data that is obtained from the population. Okay? Step 4, solve for the corresponding z-score and compute for the probability asked. So we have our raw score here is 43. Our x is 43. So we have 43 minus 46.2 all over 8, it will give us negative 0.4. So using rule 7, we solve for the probability of z to be less than negative 0.4. So that is the probability of z to be less than 0.4 is 0.5 minus, using your z table, 0.4 will give us 0.1554. So subtracting, we'll get 0.3446. So stating the final answer, the probability that a randomly selected student will complete the examination in less than 43 minutes is 34.46%. Okay? Next, example 2. The average time it takes for grade 11 students to complete an examination is 46.2 minutes. Standard deviation is 8 minutes. Now, question is, if 50 randomly selected students take the examination, what is the probability that the mean time it takes the group to complete will be less than 43 minutes? So this time we are dealing already with sample, which is 50 randomly selected students. So you already have an idea which of the two formula in finding the z-scores will we use in this example. Solving this problem, let's start with step 1. So identify the given. Your mean, population mean is 46.2. Population standard deviation is 8. Sample mean is 43 because it states here, if 50 randomly selected students take the examination, what is the probability that the mean time it takes the group to complete will be less than 43 minutes? So this mean time, that is, this pertains to the mean time of the 50 randomly selected students. So this will be our x bar. And our sample size is 50. So identify what is asked. What is asked is the probability of sample mean to be less than 43. So here the distribution is unknown. So since the sample size is greater than 30, the CLT will apply, or the central limit theorem. In this case, we are dealing with data about the sample means. Hence, we will use the formula z-score is equal to x bar minus the population mean all over population standard deviation divided by the square root of the sample size. Okay, to compute for the z-score of sample mean equals 43. So step 4, solve for the corresponding z-score. So it will give us negative 2.83. Okay, so we have z is equal to negative 2.83. So using rule number 7, we solve for the probability of z to be less than negative 2.83. That's equal to 0.5 minus 0.4977. Where did we get 0.4977? This is the corresponding value of negative 2.83 in the z table. So use your z table here. So subtracting, it will give us 0.0023. So the final answer will be the probability that 50 randomly selected student will complete the examination in less than 43 minutes is 0.0023 or 0.23%.